So a linked list is just basically, chain of little boxes, you could say. Basically, it's something like this, something like that, something like that. Twin boxes, where it has the data and it has the address to the next node. So this has this part. Okay, this part is data D, and then this is the address to the next. So this is data, address to the next. Data, address to the next. So like train box, like 1, 2, 3, 4, 5. And the train cap, it doesn't have any address to anyone because sorry. So yeah, the last one actually has address, but the address is being set to null. Okay, because it doesn't have any address. So it's just set to null. So just basically like you could just say um each you could say something like data and then we have a pointer there. So basically like box one, I mean let's say train cap one, train cap two, we have a pointer like a chain connecting both of them. Yeah, train cap three, especially like many trains if you've seen like Nigeria also we have like a lot of trains. Like one train, two train, three, four, and then all trains have been connected by chains. And then we have like last cab in there, which is connected by a chain, but it doesn't hold address to anyone. It's the last one. So it is holding the address called null. Okay, it can be stand anywhere. And why do we use is we don't need them next to each other. They can be like, in any array, any row, like an array. They're just connected by those pointers. They're not connected by the position. So that pointers are just being pointing out to different pieces. If you connect this address pointer to this part, this whole thing can be deleted. Okay, that's actually basically a way we remove and add in linked lists. When you want to add, you just send the pointer to this part. If you want to make the starting element, you just take and set the starting element. If you want to make something the end element, you just take the end element's address, you just point it to this one. That's it. So in linked list, it becomes more easy because we just change pointers. Here it says, you see here, it says here, insert and the it is easy because we just change pointers. Nodes can be stored in anywhere in memory. So yeah, nodes is basically where I'd say, um, yeah, let me see. Um, Yeah, node is just a box with two parts. Yeah, now node is basically that's just a fancy way to call linked lists boxes. So it just has two parts, data and then the address. Sorry. So basically seven is say the data, and then the next will say what is going to be the address of the next. So it's on 001789, whatever the address is. No hexadecimal or whatever the address is, binary access or whatever address has been stored in our memory. So only the next pointer connects them. So yeah, next pointer is where this case keeps getting connected. And now to each access element, we just start from head and then we just iterate through the whole thing step by step. We don't have any direct indexing, right? Because this is like a train cap. So we don't have stored in there. This is generally easy for editing. Okay, this is not easy for more efficient list and more efficient for I would say storing because they take a less memory. To access elements, it's a little simpler, but in linked list, what perks we have is if you're like a frequent change maker, if you have like a task list or you don't have to again and again append. It doesn't take much time in this. In linked list, you just need to change the pointer. So that's why it becomes quite easy. Unlike list or tuple, the other ones. It can be easy, but that generally takes up a little bit more time to run, like a little bit more program time, I mean to say, to run than linked lists. Linked lists are more efficient and quicker to run. Therefore, sometimes we prefer linked lists to run because they're that way is more simpler and more easier. So yeah, they're more flexible chain. They're not fixed arrays. Like I have an example here of a train cap kind of thing. That's how linked lists are. So basically, that's how they work internally. Just an overview of the linked lists. And just going through to the type of linked lists. Yeah, they come in different types. So we have actually singly, doubly, and circular three types. Okay, connection style defines the type. Yeah. So singly linked list is what we'll be exploring in this session. All all of them use nodes and pointers, but the difference is how the nodes are being connected. Okay. So difference is basically in where how the nodes are being connected to each other. And then the linked list can come in many different types of forms. So it's like a sundry varieties on numerous forms we have for linked lists. Literally you could have as many as possible, many different forms. But we just want to make sure, they get connected more efficiently. So it depends on the use case. You can use even simply doubly or circular linked lists, depending on the type. And now linked lists, okay, types explained. So yeah, let me explain this one real quick. So let me just zoom in. Okay, each node currently connects to the next node. Simple structure is to implement most commonly first start. Yeah, no, this one is actually the for most commonly first start, so that's why we're covering this. It's basically like a twin cap, okay? Data, address. Data, address. data. Now address is actually null. So I'll just write null. Yeah, that's it. Simple as that. That's single linked list. This is pretty easy to implement. But coming to double linked list, it can actually a little bit confusing because it has an next and previous pointer. So it has like two chains, one going to the last one, going to the forward one. Okay, each one has. So this train. So in mean doubly, what we have is like this. Let me divide that different colors so we can guys see the difference like this, and like this. So it becomes kind of complicated. It can use more extra memory and it can move forward and backward. So editing and removing and editing is kind of easy, but not that as easy as singly linked lists. Unless you really want to have double access like to next and previous pointers, we generally tend to stick to singly linked lists rather than gravitate towards doubly linked lists. Therefore, we just tend to prefer these simply ones. So, circular is basically where last node points to head. So it's like a group, I would say. I would say maybe like a dancing group, dancing circle, you could say like okay, 1 person is there, 2 person, 3 person, 4 person, 5 person, 6 person. So you see here, so this person connected this. So the end person also connected to the first person. Then first to second, third, fourth, fifth, sixth, end is also connected to the first one. So it's basically like a circle. No, none at the end, yeah. And used in looping system, yeah. Music playlists, they tend to use these kind of linked lists. Where we have, if you have used SoundCloud before, it has an option where you can, repeat something number of times. That, can repeat like limitless number of times because of this linked list. It keeps looping around. So yeah, looping listen games, they can just use a circular list. So it depends on the use case. But these are just the various different types. We don't need to explore the other two in depth for now. We just need to focus on the single ones. Let's get back to it. So we will implement these one, and we'll also learn node structure, insertion, travel. So I'll just show all of them in the VS Code as well. So okay. Now, so yeah, other types follow the same structure with small changes. So in node structure, we have insertion. So we actually want to make linked list is using classes. Okay, we make actually two variables. We make like a self.data and self.next. Okay, because we have two attributes. Self.data is equal to whatever it may be, blah blah blah, like 97 shopping mall, Walmart, whatever the data is. And self.next equals none. Okay, because if it's say just one, I would say linked list part, then it's just equal to none. Let's specify. We generally tend to, initialize that at none. But then, we can just change based on our use case. In our use case, we can just set it to whatever we want in our node. Okay, that is our node. And then we also have a class linked list. We generally tend to use both of them together because self.head, we want to set the head of our linked list to none. Then we can just set however we want. Okay, the head. Head means the starting one, starting linked list. Okay. So yeah, this we'll just explore. Now, once single is clear, those become easy. So yeah, master one structure, adapt to the rest. Yeah, that is one, I would say, key thing I will just give. Something like a poetic advice, I'll just say master one structure, adapt to the rest. So yeah, master a single linked list, and then we'll just start adapting to the next ones. Let me just grab some water, just a minute. Okay. Oh, my camera is sweet. Yeah. Okay. So now creating a node. Yeah. Now, as I said, right now, how do we create a node? Node is what basically it's specifying one box. Okay. Linked list means a chain of boxes. Linked list means linked list. Each list is linked. Innovative as that. But node means one single box. Okay. One box. Data and pointer. So what we do that for that is we just define a class. So class is just a blueprint because that's more easier to implement linked list. We could write functions as it is, but that will become more time consuming, more tedious kind of work. Wouldn't remain that I would say that easier. Therefore, we tend to use is let me just switch out this. Yeah, it wouldn't remain that engaging, that invigorating. So basically, we're just trying to use is more of a class method, object-oriented programming to model up classes. I mean, to model up linked lists, to model nodes and linked lists. So this is how we make self.data equals data. We just add up to the data. Self.next equals none. So the next is set to none. Basically it's just initialization. Data stores the values, next refers to the reference, last node next is none. Yeah. Simple as that. These are just data, next, two pieces we just have. Data and next. Key line is just node equals data plus pointer. Node is just the box. Okay. Now, what does creating the linked list mean? So, why do we create the linked list? Linked list is a chain of boxes. So data will store something like 7, hello, Walmart, shopping mall, whatever. Pointer will store link to the next node. But node only knows what's its own value and what comes after it. Okay, but a bunch of nodes, let's say you just dump in a bunch of nodes. Those are just floating nodes, right? Those aren't linked lists. They are just floating nodes. So we need something that can manage them as a group. So linked list, if you make the class like I made here, that is basically the manager. The head points to the first node. Initially, it's none because the list is empty, and then it starts getting pointed. Okay, so linked list is basically the manager. So basically, I would say the big box that keeps all of these compartment ranked, raked with raked with I would say those hanging chains. It's just been attached with the hanging chains. All of that is been held together by that linked list. It's a big compartment kind of thing that's holding it together. So yeah, all operations start from the head. So that's where we get